All right, so composite functions. So what do you think of when you see the word composite, composition, compose? What does it make you think of? Makes me think of English class, writing compositions in my composition notebook, right? So the prefix co means together. Posit, position, you position things together. In a composition, you pull together all of your thoughts and ideas. A musical composition is a pulling together of all the musical notes. If you compose yourself before you're ready to speak, you are gathering and pulling together your emotions, calming yourself down. So co means together. And so when we do composite functions, we are going to do two functions and we're going to put them together. That's basically what's happening. All right, so our notation, it's an F with a little circle, and it's an open circle like that, and then a G of X. So this says F composed with G. Little open circle. This is not a multiplication sign. Okay, it's not multiplication. Some people get that confused because sometimes we do use a dot for multiplying, but this little open circle, not multiplication. All right, another way to write your composite function would be to say F and then of G of X, like this. So we have these parentheses inside of parentheses. So that's the symbolic notation. The way to say it, you would say F composed with G, or you could just say F of G of X. Alright, so we're going to jump in with a couple of examples and just work through these. So I'm going to start with function F of X. Let me give you guys the same example as the other class. Let's see, where did I put that? Hello, this is Miss Collier. Alright, so we're going to start with f of x being a linear function, x plus 3. And then our g of x is going to be the quadratic function, x squared minus 1. In my opinion, the key to doing this is to focus on the idea of inputs and outputs. Don't get too focused on the variable, but think of input and output. I'm going to give you a kind of concrete way to look at this. You do not always have to draw these boxes. All right, this is just what I'm going to do for the first two. So if I take f composed with g of x, or it can be written f of g of x, here's what that means. That means I start with an input of x. And the first thing I do is I put that x into function g. So I take x, put it into function g. So here's my g of x. This is my little function machine. Put this input in here. G of x operates on it. You hear gears shifting, whistles blowing, and g of x outputs x squared minus 1. Right? Input, output. I then take that output from g of x and I enter it as the input for the function f of x. So the function f of x says, whatever your input is, take it and add 3. So now my input is x squared minus 1. So I take that input, x squared minus 1, and I add 3. So this right here that's where my input went. See? Don't think of this as x plus 3. Think of this as input plus 3. And now my input is the output from g of x. And then I just take that and simplify it down to x squared plus 2. How we doing? Show me. Getting it? Remember it from Algebra 2? Kinda, sorta? Alright. Composing functions is not commutative in general. So if I put it in the other order, it's going to come out different. So if I have g composed with f of x, and sometimes for me it helps me to write it in the other notation, g of f of x, because this kind of helps me see, okay, I'm going to put x into f and then I'm going to go to g. So we always work from our inner parentheses out. So if that notation helps you better. So this time I'm going to start with an input of x, and I'm going to input that into the function f of x. Well, f of x says when you put something in, you take the input and you get 3 more. So out comes x plus 3. So this output now becomes the input for g of x. Well, what does g of x say? G of x says take the input, square it, and then subtract 1. So that means I'm going to take x plus 3, because that is my input value, square it, and subtract 1. So I'm going to come here and write x plus 3 times x plus 3 and bring down my minus 1. Remember, you do not just pass out that exponent. You don't. Exponentiation does not distribute over addition. We have to come on and distribute here. So x times x gives me x squared. X times 3 is 3x. Hold that in my brain. 3 times x is 3x. Combine those like terms. That makes 6x plus 9. If you want to write that step out, you can. I think most of you do that part in your head. Remember to bring down the negative 1. Don't forget about it. And then we have x squared plus 6x plus 8. All right. Take a pause. Talk with your partner about f composed with g versus g composed with f. Do you remember this from Algebra 2? How many people do remember it? How many people are like, nah, not connecting with me? Okay. All right. Talk to these with a partner.
Okay. So f composed of g, where you input g into f, or into f. And g composed of f is where you input f for x, right? Sorry, is this
Hard to say. Basically, just plug it in.
yeah, that's exactly
The easiest squared thing. Right. But at least it's a practice, so you get to have fun. I love practice. I mean, it's so scary though. That tournament's really scary.
Yeah, it's definitely
Alright, so let's come back together. I'm noticing that some of you are like, yes, I totally remember this and it's easy. A few people are a little confused in the beginning, but I love how you helped each other out. Alright, let us add one more piece to this. So, you can also compose a function onto itself. So, I'm just going to rewrite f of x here so I can see it. So, f of x is x plus 3. So, if I did f composed with f of x. So, take the input of x, plug it in here, you get x plus 3 for your output. Now you're going to plug x plus 3 in. That is your input plus 3. Right? Because function f says input plus 3. But my input is going to be x plus 3. Because that was my output the first time I put it in. So then that's going to be x plus 6. Alright, let's do the same with g of x. G of x, I'm just going to rewrite it here so it's on my screen. G of x was x squared minus 1. So if I do g composed with g of x, now if I write that in the other notation, it's g of x. And so, again, just a little bit of a warning. Don't take a quick glance at either one of these and think that it's multiplication, right? You need to be able to look at that and go, oh, that's the composite function. So, if I plug x in, I get x squared minus 1 out. So then, my input is x squared minus 1. And my function says, take the input and square it and minus 1. I'm going to go ahead and write out x squared minus 1 times x squared minus 1, and then bring down my other minus 1. And then I'm going to distribute x squared times x squared, x to the 4th. X squared times negative 1, negative x squared, hold that in my head. Negative 1 times x squared, that's another negative x squared. Put those two together, combining like terms to negative 2x squared. Negative 1 times negative 1 is positive 1. And then don't forget about that negative 1 over there. Then my plus 1 and my minus 1 add up to 0. Now x to the 4th minus 2x squared. Alright, let's see if you've got it by trying these two functions. Alright, so this time, let's take g of x being equal to 3x, and we'll have h of x being equal to x squared. Alright, so first I want you to compose f of g of x. No, you can't do that. There's no g. There's no f. Let us compose g of h of x. So sorry, guys.
No, I think we should flip those two back.
All right, what'd you get for that? 3x squared, right? The output for h of x is x squared, so that x squared goes right there for the input, and it's just 3x squared. Okay, now do h composed with g of x. What did you get this time? Alright, this time we should have 9x squared. So look at what we have. G of x is worth 3x. H of x says take your input. What's my input? 3x. And square the whole input. So that's going to give you 9x squared. Alright, now try g of x. G composed with g. What did you get for that one? 9x. Plug in x for g of x. You get 3x. So then take your framework. It says 3 times my input. But my input is 3x. So that's 9x. So sometimes, like putting a little line for the input or putting the input in a different color, I don't think you have to go through drawing those boxes, but if that helps you to see the progression, but sometimes just little lines or different colors can also be helpful little techniques. All right, finally let's do h composed with h of x. Alright, what'd you get that time? X to the 4th. So h of x gives me an output of x squared. My h function says take your input and square it. But if I'm putting an x squared in there, x squared squared is x to the 4th. Right? Alright.